let's get started with the interview. A lot of people already have done this, and let me quickly see if there's like already there's a ton of questions, and so
okay.
I do also have like some questions prepared, but let's see what questions from the audience I can show you. So we're starting with a question from Andre Sisu. If I want to gain enough knowledge, not necessarily to become a contributor to LLVM, but just to be able to experiment with implementing new language features I may have in mind, so they are a committee member. Will this book give me the required jumpstart? Also, to what extent is the book useful for people without prior compiler background?
So for the first question, like if the book will help you with language features, I think there's two aspects here. It's like how much of the language feature are actually impacting the C++ syntax itself, and how much of it is pure backend. Like let's say you're adding a pragma that allows you to do some security check or whatever. That part will be wired up automatically by the existing front end. And then indeed the book can give you the ropes to essentially then implement that feature in the backend. Now, if your language feature needs to modify the front end, like for instance, when auto was introduced, and that where you need to have some type inference and stuff like that, the book is not going to help you at all. I do not cover the front end part at all. It's really a different world, and that's not my jam. Let's put it this way. Now, with respect to the second part of the question, like would that book will be useful for people without compiler background? I would say absolutely. That's why chapter 3 and 4 are here, to give you the concepts that you need to work in the backend. But again, those concepts are for compiler backend. Like it's not going to talk about abstract syntax tree and making sure your semantic is correct and your type inference is correct. All that is not covered by the book. So compiler background, yes, but compiler backend background.
Yeah, so I think that's an important distinction which we should make, is that the book is not like specific about Clang and C++ implementation, but more about what follows when the translation happens from that to LLVM and its internals. So if you're working on language-specific features, then the book will help you to understand what these gets translated in and be like LLVM-specific details. Let me see the next question. So Nicola Fogg asks, if I had a custom processor, would I be able to port Clang to that processor given the information in this book? Is there a hands-on exercise for porting LLVM to a new processor?
So absolutely, that's kind of the point of the book, to give you all the information you need to build a custom process or custom backend. So I would say, depending on what you mean by custom processor, you need to be careful, as in there are some information that usually are given to you by the architect of your processors, like things like what are the instructions that are supported by your processor. So if you're trying to build yourself your custom processor, you have to think about what are the instructions I want to support to be able to implement them in the backend. But separate discussion. So short answer is yes, that is what you need here. And with respect to, is there an hands-on exercise for porting LLVM to a new processor? Absolutely. And actually, the book comes with a GitHub repository where I step by step commit a new backend. I show you from doing nothing to having your backend being connected to Clang, to how you can produce assembly from C++ to your new custom processor. So just to set the expectation, it's a toy processor, so it doesn't do fancy things, but at least it gives you the idea of how you plug the different things so that it works end to end.
But yeah, that's my impression from the book is also that it definitely will help you to get started with, getting a feel what you need to do for doing this. And then, I mean, we saw that the book is already quite in-depth, but like going like into custom processors and even more in-depth, and you have a very specialized book.
Yeah, absolutely. I would say the idea of the book is show you how things works so that you can go beyond what's in the book.
And then a bit of a simpler question. It's like LLVM is the compiler. Why do you have to run Clang, and LLVM can work even without Clang? Or so they are tied to each other. Let's go with that.
Yeah. So there is actually something called LLC, so the LLVM compiler. So you can actually run the compiler without Clang. But here's the catch, is that LLC is about compiling from LLVMIR to assembly. So if you want to program in LLVMIR, be my guest. But I would think that you would prefer to program with a higher level language. And that's what Clang++ does, is essentially your companion to produce the LLVMIR that represents your C++ program. So again, this notion of front-end versus back-end. And when you look at Clang, it's actually more than a front-end, it's actually a driver. And under the hood, it called the preprocessor, and then it called the actual parser and all that stuff to do the C++ lowering to your LLVMIR. And then it calls the LLVM compiler. And then depending on what you want as output, like if you want an object file or if you want an assembly file, you may even call the assembler for you. So Clang is really a driver that allows to stitch all the pieces of LLVM together so that you don't have to do it by hand.
So the book has like build instructions, but are you also familiar, or is the book helping you with building Clang under Windows?
No. So I know that in the book I point to the official documentation where I think they cover Windows, but I didn't have a Windows machine myself to test things. So everything that you see in the book has been tested by me. So I know it works. And since I didn't have Windows, I didn't put anything on Windows. So it's in that sense, it's uncharted territory, but it should work.
And I see there's a follow-up question from Nikolai. In addition to my previous question, so I see that there is a book like Learn LLVM 17 Second Edition. Which book would be the best to read if you wanted to add a new CPU architecture to as a backend?
Yeah, so if you want to add a new CPU architecture, I would say my book is much better, because if you look at the LLVM 17 book, the backend part, and it's true for pretty much all LLVM book out there, there's no book that covers the backend part. So everything that you saw, so first of all, the table gen part, which is an important tool in LLVM, is not covered from what I remember. But more importantly, all the thing about the machine IR, register allocation, instruction scheduling, encoding, and all that stuff are not covered in those books. Those books are, I would say, focused on the, in a sense, what makes LLVM, which is really the middle end. And my book is really about the back end of the backend, if you want. Also, just for what it's worth, the book is based on LLVM 20.
So, someone asked, does this book cover MLIR? And What?
No. So I don't know of a book that covers MLIR. So funny story, I actually work on LLVM for the past 3 years. I wanted to cover it, but the book was too big already, so I ditched it. But essentially, MLIR is another intermediate representation that sits on top of LLVM. So in that sense, you could kind of say it's a front end. The reality is that it's more type of a middle end, but yeah, I do not cover that at all in that book.
Okay.
And yeah, I don't have any recommendations, sadly.
And then there's, of course, the question, like, would you recommend any complementary book focusing on the front end?
Yeah, no, I cannot make any recommendation there. It's kind of, I kind of feel embarrassed that I have to admit that everything that is above LLVM is kind of syntactic sugar for me, so I'm not super into that type of thing. So I kind of am oblivious to all that stuff. So sorry, I cannot give you good recommendations there.
All right, so there's a question which didn't show up here, so I copied it, and it shows now up here. So you seem to be at least a contributor to GlobalISel, which, we probably first need to translate this question to the audience, right? What are these?
Yeah.
And I quickly checked that this is something which is in LLVM, so that question makes sense. So
yes. So ISL stands for instruction selection, and global is the framework. So instruction selection, there's different frameworks in LLVM to do instruction selection, and I cover that in the first chapter, like getting started in the first chapter on instruction selection. Like the getting started with instruction selection covers the differences between the different instruction selection frameworks. So I would say there's not one major. Well, there's several differences. The major one is the global part of the instruction selection. So the global instruction selection is global to the function, meaning that when you're lowering your code from LLVM IR to machine IR, you have a view of the whole function at a time. So meaning that you can make decision of the instruction that you want to use based on the full context of the function. Whereas when you look at selection DAG has a much narrower view, where to put it in C++ term, you essentially see one block of your function, like what you have between two curly braces. So that means that you have much less context to decide what type of instruction you want to use, and it also limits the type of optimization that you can do, because if like when you have your variable that is produced in a statement, and then if it's used in a different block, you may not see how it has been produced in selection DAG. So that means that there are certain optimization that you may not be able to do. So in that, I would say the major difference again for GlobalISel is the scope that you see, and that means that you can do cleverer optimization. Then there's a bunch of other differences. I would say two of the big ones are GlobalISel is purely written in machine IR, so using just the machine IR. Whereas selection DAG has its own also intermediate representation, and that has two impacts. The first one is that selection DAG is slower in terms of compile time. It's yet another IR translation that you have to do in your compiler pipeline. So that means that the user of the compiler will spend more time waiting for the compiler to do his work. And the second thing is that since selection DAG uses its own intermediate representation, you cannot actually pair it with a generic optimization that you can do in GlobalISel. I'm not recommending that at all, but for instance, in GlobalISel, you could put your instruction scheduler between the legalization phase and the action phase or something like that. So what I'm saying is that GlobalISel is much more flexible, it's more modern, and that means it's easier to develop and debug. And when you put all things together, so better scope, better compile time, and better flexibility. And yeah, I'm a major contributor of GlobalISel because I haven't it, so I'm kind of biased in my answer.
So this is basically a question which I just come to my mind. You know, compile times are such a big issue for C++. How much work does LLVM do in parallel?
So sadly, very little. So one of the problems is that, and it's like a problem that the community is very well aware of. So one of the problems is that LLVM relies on the type uniquing mechanism that is relied on when you're doing optimization. Like when you're checking if, for instance, two variables are using the same type, you do that by just checking if the pointers are the same. So the underlying C++ object is the same. So now if you start to having things that runs in parallel, that means that those types may be created by different threads, and they could be some race condition and all that. That makes that the type uniquing is pretty much broken at this point, and then optimization will go not where you want. So I guess long story short, the parallelization work in LLVM is pretty much inexistent at this point.
Okay.
Sadly.
So if you want to get started on that, that's a great book to get started on this journey. Let me see. I also have a few questions myself. So let's get basically back to the book, right? Something we haven't talked about at all. Like, what is the audience you had in mind when you wrote the book?
So the audience I had in mind were, I would say, two different kind of publics. So the first one is actually students started in compilers and wanted to really learn the how compiler internals works, and I mean really the backend part. So I guess to step back a little bit, when I learned compiler at school, we spent a lot of time about abstract syntax tree and all that stuff, like how do you make sure that the language is typed properly? And personally, I found that very boring. So that book is actually covering what's happening after, which is how do you actually produce code for your actual processor, which may or may not be covered in classes nowadays. But yeah, essentially it was okay for compiler enthusiasts that are interested into getting into backend world and see how things works under the hood. And the second audience was people that may already know this type of world but never worked with LLVM. So I wanted to break it down how things work in LLVM and how you use the LLVM tool to really get started and then either contribute to existing backends or write your own. And again, all what's in the book is based on what I saw people asking me over like the last 15 years or something like that.
Yeah. So basically, I see that basically your own teachings have led to this book. And so what did you learn about C++, but also about LLVM while writing this book?
So I wouldn't say I learned. So I would say I learned things about LLVM because when you have to explain things, when you work with LLVM, sometimes you make some assumptions, and when you have to explain things to people, you have to actually check that your assumptions are correct. So in that sense, I was able to confirm or deny some of my assumption and correct them and show them properly in the book. Like things, for instance, around how the encoding works so it's all based on table gen, again, this DSL, but there are so many indirections that it's kind of easy to get lost in translation per se. And I had really to sit down and it's like, okay, I've been doing that for years, but actually, how does this connect in the backend? And it was kind of surprising to, even after working with LLVM for more than 10 years, to actually see, oh, okay, that's how it works. So that part was funny. With respect to C++ itself, I would say nothing in particular. I've just been using C++ a lot, and LLVM usage of C++ is pretty basic. Like there's no exception, no complicated. Well, there's a little bit of template method programming, but not so much. So all I would say the fancy C++ things are pretty much not there. So in that sense, the LLVM code base is huge, but the implementation in terms of C++ is actually pretty basic.
So you are saying there's room for improvement?
Yes and no. I like basic, let's put it this way.
All right. So,
like for instance, one thing that's interesting in LLVM. Oh, sorry. I just wanted to learn one thing that's interesting in LLVM is that there's no RTTI, so no runtime type checking. And LLVM rolled out its own runtime type checking. Is actually everything is static and is based on enum and all that stuff. It's kind of an interesting pattern, but it's I would say it's a nice trick to see if you've never seen that in C++, but it's not like rocket science and whatnot.
And so this is a big book, and this just released actually. The first ebook which Pact sent me had like big printed on every page, Pact internal, do not share this. And then I'm glad that, this is a big book, but you can't write such a big book without making errors. And this is a complicated topic, as you said, as you yourself learn like how things actually work when writing the book. So do you have any known errors in the book or things?
I have one right now. It's a minor one. It's so each chapter. So the way the book is structured is that at the end of each chapter there's a quiz to see if you kind of understood what you read, or also the way I actually wrote it is that instead of reading the chapter, you can start with the quiz, and if you see that you can answer the quiz easily, then maybe you already know what's in the chapter, so you can move to the next one. So anyway, back to the errors in the first chapter. So it's kind of sad. It's like the first chapter and it has an error. In the answers of the quiz, one of the answers is badly labeled. So you think it's the next question, but it's actually the answer of the previous question. So be aware. So like you say, there's it's a big book, so there are errors. That's for sure.
All right. Then I guess if you have any more questions about the innards of LLVM and generally, but of course, I already have a feeling that there's like a few chapters which are potentially in there, as we talked about MLIR. So
correct. Yeah.
What didn't make it to the book?
There's actually a whole lot that didn't make it into the book. So that's kind of funny because I've been working on LLVM for almost 15 years now, and at first when I wrote the table of content for the editor, because you essentially have to make a plan of what you think you're gonna speak about, I was actually thinking that the book will be short. And as I was writing the table of content, there were more and more stuff that were piling on. And when I said, okay, that's fine, I can talk. Like, for instance, if you look at the chapter on register allocation, it tells you how to leverage the existing infrastructure to do your register allocation, so to assign those registers to your instructions. And I'm actually the code owner in LLVM for the register allocators, and I know how they work inside out, and it's not very well documented. So I wanted to use the book as an opportunity to really documenting very well how the algorithm work and what are the different phases and all that stuff. And actually just writing about how to use it already, the chapter, I don't remember how many pages it is, but maybe 30 or 40 pages. And okay, it's probably already long enough. So I will not spend maybe the next 120 pages explaining how it actually works. So that's the type of things that it's kind of an interesting exercise, that as you do this introspection mechanism of, okay, what can I teach other people, you realize that you know much more than you thought. And there's like a small tricks and tips that are super useful that you wish you knew and you want to talk about it, and then you end up spending pages about explaining the context and how that works. So in the end, a lot of I would say gory details have been left out. So same thing on the instruction scheduling, same thing with GlobalISel and actually selection DAG. So like another example is in selection DAG, a lot of the things that you do are driven by the table gen DSL, and that's a declarative language. Like when you see this type of IR produce this type of instruction, very simple. The thing is that what LLVM does is actually producing an automaton that runs through the IR and jumping back and forth, like if blah blah, many operands, blah blah blah. And the automaton is like a massive file of it's actually a big C++ table with a bunch of enums and bytes offset in the table and whatnot. And I wanted to explain how that thing works. And after just explaining how to write the DSL, the chapter was already too long. So I was, okay, if people want to know how it works internally, I guess that would be for the advanced LLVM Code Gen, or will just ping me, because it's just too long to document all that stuff.
All right. That, I think, brings us to the end. Thank you, Quentin, for your time. That's really an interesting book, and it's a very
making with them.
And so if you're interested in working on LLVM, and if you're interested in, maybe having the job to port certain processors or new hardware to an LLVM backend, that is the book you want to read.
Thank you, James. And I would say, don't be shy. Feel free to reach out on LinkedIn, on Discord. Like LLVM has a public Discord server. I'm lurking there, so say hi. Happy to connect, and enjoy your backend journey. And again, thanks a lot, James, for making this meeting happen.